Juniper JN0-351 exam practice questions with explanations are available in the video for you to study. What accurately describes the behavior of graceful routing engine switchover (GRES) on a Junos device? A. The packet forwarding engine (PFE) restarts, causing loss of kernel and interface state. B. GRES includes both a helper mode and a restarting mode. C. When used with non-stop routing, NSR, routing is maintained and the new master routing engine does not restart the RPD process. D. Even without other high availability features, routing is preserved and RPD does not restart on the new master re. The answer is C. The graceful routing engine switchover (GRES) feature in Junos OS enables a router with redundant routing engines to continue forwarding packets, even if one routing engine fails. GRES preserves interface and kernel information, ensuring that traffic is not interrupted. However, GRES does not preserve the control plane. To preserve routing during a switchover, GRES must be combined with either graceful restart protocol extensions or non-stop active routing (NSR). When GRES is combined with NSR, nearly 75% of line rate worth of traffic per packet forwarding engine remains uninterrupted during GRES. Any updates to the primary routing engine are replicated to the backup routing engine as soon as they occur. Therefore, when GRES is combined with NSR, routing is preserved and the new master re does not restart RPD. In a Junos BGP configuration, what is the default interval for sending BGP keep alive messages? A. 10 seconds. B. 60 seconds. C. 30 seconds. D. 90 seconds. The answer is B. In BGP, two timers are especially important. Hold time. The maximum time a router will wait without hearing a keep alive before considering the neighbor down. Keep alive time. How often the router sends keep alive messages to maintain the session. By default in Junos, and in general BGP implementations, hold time equals 90 seconds. Keep alive time equals 10 seconds. This means a BGP router sends keep alive messages every 10 seconds to ensure the peer remains reachable. You are setting up an ISIS network, but ISIS adjacencies are not forming. Which two issues could be causing this problem? Choose two. A. The MTU is less than 1,492 bytes. B. IP subnets are not using 30 addressing. C. Level 2 routers are configured in different ISIS areas. D. The loopback, low zero interface is not configured for ISIS. The answer is CD. C. The level 2 routers have mismatched areas. ISIS routers in level 2 must be in the same area to form adjacencies. Unlike level 1, where each area can be different, level 2 routers require area consistency. D. The low zero interface is not included as an ISIS interface. In Junos, you should include the loopback interface, low zero, under the ISIS configuration. Without it, you won't have a stable router ID or proper reachability, especially for LSP origination and SPF calculation. As a network operator, you're adding a second ISP and replacing the current default route by deploying BGP. Which two statements about BGP behavior are true in this scenario? Choose 2. A. BGP updates the next hop attribute to ensure reachability within the AS. B. IBGP peers advertise routes learned from eBGP peers to other IBGP peers. C. IBGP peers advertise routes learned from other IBGP peers to additional IBGP peers. D. eBGP peers can advertise routes learned from IBGP peers to other eBGP peers. The answer is BD. B. IBGP peers advertise routes learned from eBGP peers to other IBGP peers. This is true. One of IBGP's main roles is to distribute eBGP learned routes within the AS. However, you must have a full mesh of IBGP sessions, or use route reflectors or confederations, since IBGP does not forward routes learned from other IBGP peers. CC. DEBGP peers can advertise routes learned from IBGP peers to other eBGP peers. This is also true. An eBGP speaker can advertise any route it knows, including from IBGP, to external peers, as long as policies permit it. While troubleshooting BGP routing issues between your network and a customer router, you examine the BGP routing policies. Which two statements about when import and export policies are applied are correct? Choose 2. A. Export policies are applied to routes in the RIB-IN table. B. Import policies are applied to routes in the RIB local table. C. Import policies are applied after routes reach the RIB-IN table. D. Export policies are applied after routes are in the RIB local table. The answer is CD. Import policies are applied after routes are received and placed into the RIB-IN routing information base incoming table but before they are installed into the RIB local, the table used for local forwarding and routing decisions. Export policies are applied after routes are installed in the RIB local table and just before sending the routes out to neighbors. On a Juniper X-series switch, you need to connect both an IP phone and a user computer to the same interface. The computer's traffic is untagged, while the IP phone's traffic is VLAN tagged. Which feature allows the interface to accept both tagged and untagged traffic correctly? A. Native VLAN. B. DHCP snooping. C. MAC limiting. D. Voice VLAN. The answer is D. The feature that enables an interface on an EX series switch to receive both untagged traffic from the computer and tagged traffic from the IP phone is the Voice VLAN 12. The Voice VLAN feature in X-series switches enables access ports to accept both data, untagged, and voice, tagged, traffic and separate that traffic into different VLANs 12. This allows the switch to differentiate between voice and data traffic, ensuring that voice traffic can be treated with a higher priority 12. Therefore, option D is correct. You have enabled DHCP snooping on a new X-series switch. but no entries appear in the DHCP snooping database for a particular interface. Which two interface configurations could cause this issue? Choose 2. A. The interface is configured as a disabled port. B. MAC limiting is enabled on the interface. C. The interface is configured as a trunk port. D. Dynamic ARP inspection (DI) is enabled on the interface. The answer is AC. A is correct because the interface is configured as a disabled port. A disabled port does not forward any traffic, including DHCP packets. Therefore, DHCP snooping cannot learn any MAC addresses or lease information from a disabled port 1. C is correct because the interface is configured as a trunk port. By default, all trunk ports on the switch are trusted for DHCP snooping too. This means that DHCP snooping does not inspect or filter any DHCP packets received on a trunk port. Therefore, DHCP snooping does not add any entries to the snooping database for a trunk port 2. Which two statements correctly describe the characteristics of RSTP alternate ports? Choose 2. RSTP alternate ports block traffic while receiving superior BPDUs from a neighboring switch. B. RSTP alternate ports provide an alternate lower cost path to the root bridge. C. RSTP alternate ports provide an alternate higher cost path to the root bridge. DRSTP alternate ports are active ports used to forward frames toward the root bridge. The answer is AC. A is correct because RSTP alternate ports block traffic while receiving superior BPDUs from a neighboring switch. An alternate port is a backup port for a root port, which means it receives better BPDUs from another bridge than the current root port 1. However, an alternate port does not forward any traffic, as it is in a discarding state too. It only listens to BPDUs and waits for the root port to fail. If the root port fails, the alternate port can immediately transition to a forwarding state and become the new root port 1. C is correct because RSTP alternate ports provide an alternate higher cost path to the root bridge. An alternate port is selected based on the same criteria as the root port, which are the lowest bridge ID, the lowest path cost, the lowest sender port ID, and the lowest receiver port ID 3. However, an alternate port receives a higher cost BPDU than the root port, otherwise it would be the root port itself 1. Therefore, an alternate port provides an alternate higher cost path to the root bridge than the root port. Which two statements about the default VLAN on Juniper switches are correct? Choose 2. A. The default VLAN has a VLAN ID of 1 by default. B. The default VLAN ID is not assigned to any interface. C. The default VLAN ID is not visible. D. The default VLAN ID can be changed. The answer is AD. On Juniper switches, the default VLAN is set to a VLAN ID of 1 by default 12. This means that all interfaces on the switch are members of VLAN 1 until they are specifically assigned to another VLAN 12. Therefore, option A is correct. The default VLAN ID can be changed 12. This allows network administrators to configure the switch to use a different VLAN as the default, if necessary 12. Therefore, option D is correct. When configuring a link aggregation group, lag, between switches, which two statements are true? Choose 2. A. Duplex and speed settings do not need to match on both ends of the member links. B. Duplex and speed settings must match on both ends of the member links. C. Member links must be contiguous ports on the switch. D. Member links do not need to be contiguous ports on the switch. The answer is BD. B. Duplex and speed settings must match on both participating devices. For stable lag operation, all member interfaces must have the same speed and duplex settings to avoid mismatches and issues. D. Member links do not need to be contiguous ports. Lag members can be any ports on the switch. They do not need to be physically adjacent or contiguous.